The final topic covered on test number 5, from my understanding, it is going to be these P10 notes that we did yesterday. So I wanted to make sure that you guys had access to these in case you were absent or in case you needed to refresh your memory or watch them again. And so what we are doing is we are figuring out the point of intersection where this equation intersects this equation. So this is a quadratic, and it would look something like that because it's got a negative. And then we would have a line that looks like that, and so they're going to be intersecting each other. And sometimes you'll have just one point of intersection, so you might have had a quadratic that does this, and that line just barely touches it like that. Sometimes you could have no points of intersection, of course. And we've done these graphically, but we've never done these algebraically before. But the method for solving any system is actually basically the same. Now, granted, you're doing it with more difficult equations, but it says here in the instructions, and I know I've covered them up with more white paper so that I have more room to do my work on my iPad. We're going to do the substitution or the elimination is what it says here. So what I did in class was I did this one with substitution, and then I did the second one, question number 2, with elimination, which is why the assignment grade was only for numbers 3 through 9. Okay, so what I did when I did substitution was I took this second equation and I subtracted the 2x to move it over. So I had y equals negative 2x plus 4. And then I took this equation and I substituted for y in the first equation. Now, what I'm technically doing when I do that is I'm setting the two equations equal to each other. And that is a technicality, but what you may or may not have ever been told is that when you set two equations equal to each other, that's what you are doing, is substituting the equations for y. And so now we have a quadratic that we can solve. And so if I'm going to solve it, of course, I need it set equal to 0, just like the overwhelming majority of all of our other quadratics. So I'm going to add the 2x to move it to this side, and I'm going to subtract the 4 to move it to that side as well. And that'll give me a 0 on the left. The negative 2x squared stays negative 2x squared. Adding the 2x makes this become a positive 18x. And then subtracting the 4 makes this become a minus 36. Now, I can take the whole equation and I can divide it through by negative 2, but I didn't do that in class. Some of you guys are very good with that kind of thing. Some of you guys sometimes make arithmetic mistakes with any extra steps that we ask you to do, and only you know whether you're comfortable with that or not. And so what I did was I just factored the negative 2 out, just because I want to make sure that I do the work with the same consistent steps no matter what it is we're doing with this equation. So I just pulled the negative 2 out. You can divide it away this time. It doesn't always divide away, but it makes it become an x squared and a minus 9x and a plus 18. And then what happens is I can factor that quadratic. And so this quadratic factors as x minus 6 and x minus 3. And so this factor gives me a solution of x equals 6, and this one gives me x equals 3. Now, if this had been our starting point right there, we'd be done. We would know our x values that are solutions to that quadratic, but that's not our starting point. Remember, we're looking for the points where these two equations intersect each other, and points require an x and a y coordinate. So the last thing that I did on this problem was I took these two x values that were our solutions, and I plugged them into the linear equation to get the y coordinate. So I have y equals negative 2, plug in the 6, and when I do that, I get negative 8 as my answer. And so that means the point 6, negative 8 is one of the points of intersection. And then when I plug in the 3, I get negative 2. And so that means the point 3, negative 2 is my other point of intersection. And so now that problem is done. Okay. Question number 2 can be done the same way. Absolutely. You can take this equation and you can set it equal to this equation. And the reason I didn't do it is I wanted to show them the other method. I wanted to show them elimination. So just real quick before I actually do the elimination method on this problem, I just want to remind you that elimination, when we were back in our linear system, what you did was you made sure that the x's and y's were lined up. So let's say I was doing 2x plus 3y is equal to 5. And then let's say 2x minus 4y is equal to, that's negative 7, whatever. I'm just making up equations. And you lined everything up. And then you had to figure out whether you were going to add or subtract the two equations to cancel stuff out. Okay, so you just added or subtracted straight down because everything was lined up. Well, this system that we've been given, the equations are already lined up. We've got the y's isolated on the left side, and we've got all of our x's on the right side. So I'm going to take those two equations, I'm going to subtract them. And so when I do y minus y, I get 0 on the left side. And then on the right side, I've got this 2x squared up here, and there's no quadratic term down here, so I have nothing to subtract from it, so it just stays 2x squared. And then up here, I have no linear term. I have no term that's just got an x attached to it. And so then I'm just going to subtract the minus 5x, which makes it become a plus 5x. And then last, I have the minus 3 up here with no constant down here to subtract from it, and so it just stays a minus 3. Okay. Now, we didn't go over factoring methods yesterday, so you can look back at the other videos that have factoring methods on it. But this quadratic does factor, and it factors as 2x minus 1 and x plus 3. So what I would suggest is if you're watching this video to either make up the notes or to just refresh your memory or go over them again before the test or something, I would pause right now and I would factor that quadratic and make sure you can get the correct factors. Okay? If you are either done pausing it or if you are not going to pause it, then you know that the next thing we would do is this factor right here would give us a solution of 1/2, and this one would give us a solution of negative 3. And then, because I'm looking for the points of intersection, I would take each of those x values, plug them into one of the equations. Once again, I personally would plug it into the linear equation. So if I plugged the 1/2 into the linear equation, I would get negative 5/2 as my answer. And so that means my first point of intersection is 1/2, negative 5/2. And then I would take the negative 3 and plug it in as well to the equation. And negative 5 times negative 3 is positive 15. And so the other point of intersection is the point negative 3, positive 15. And there's my 2 points of intersection. Okay, so that's what we did on the P10 worksheet as our notes. And then the assignment was number 3 through 9 to do for a grade.